Mobile computing, learning objectives. In this chapter, the user would learn the following in detail: concept of mobile computing, basic architecture, mobile devices, limitations of mobile devices. Basic architecture. Programming languages. Programming languages used in mobile computing architecture are Java. Platform independence. Program codes written in Java are independent of the CPU and OS used in a system due to standard compilation into bytecode. Java J2SE has two limited memory-sized editions, J2ME, Java 2 Micro Edition, and Java Card, Java for Smart Card. Most used languages for developing applications for a mobile device platform. The Java Enterprise Edition, J2EE, used for web and enterprise server-based applications of mobile services. C and C++. Program compilation depends on the CPU and OS used. Inline assembly code can be used directly. Gives compact machine-specific codes. Visual C++ and Visual Basic, used for pocket PCs with Windows platform. .NET, widely used framework for mobile application development. Python 2.7, popular platform for mobile applications. Operating systems. An operating system enables the user to run an application without considering the hardware specifications and functionalities. Provides functions which are used for scheduling the multiple tasks in a system. Provides management functions such as creation, activation, deletion, suspension, and delay for tasks and memory. Provides the functions required for the synchronization of multiple tasks in the system. Multiple thread synchronization and priority allocation. Provides interfaces for communication between software components at the application layer, middleware layers, and hardware devices. Facilitates execution of software components on diversified hardware. Provides configurable libraries for the GUI, graphic user interface, in the device. Provides user applications, GUIs, VUI, voice user interface components, and phone API. Provides the device drivers for the keyboard, display, USB, and other devices. Also provides middleware applications and new application development environment. Some of the popular operating systems used in mobile computing are Symbian OS, Windows CE, Palms OS. Middleware for mobile systems. Middleware are the software components that link the application components with the network distributed components. Mobile OS also provides middleware components. A few examples of middleware applications are to discover the nearby device such as Bluetooth, to discover the nearby hotspot, for achieving device synchronization with a server or an enterprise server, for retrieving data which may be in Oracle or DB2 from a network database, for service discovery, for adaptation of the application to the platform and service availability. Mobile computing architectural layers. Defines various layers between the user applications, interfaces, devices, and network hardware. A well-defined architecture is necessary for systematic computations and access to data and software objects in the layers. Mobile computing architecture for a mobile device. Mobile computing architectural layers. Two adjacent layers interact with each other through input-output interfacing. An application deploys the software components and APIs, application program interface, at application layer. The client APIs can be considered as the uppermost layer in the architecture. There are middleware components which discover the service, link the client and network service, update database, manage the device using remote server software, perform client-server synchronization, and adapt the application to the given platform and server. OS is a layer in between the application and hardware. It facilitates the running of the program, hiding the specifications of the hardware, and provides many OS functions, example, device drivers. Protocols. Interchanges between two diversified and distributed components need protocols and standards. Mobile computing services use a number of mobile communication protocols such as GSM 900, GSM 900, 1800, 1900, CDMA, WCDMA, HSPA, UMTS and iMode, LTE and WiMAX, WPAN protocols, Bluetooth, IRDA and Zigbee, WLAN protocols, for example, 802.11a and 802.11b, WAP, Wireless Application Protocol. Mobile computing architecture layers. There are different layers in network transmission and reception or in interchange of information. The OSI, Open Standard for Interchange, 7-layer format is as follows. Physical for sending and receiving signals, for example, TDMA or CDMA coding. Data link, for example, multiplexing. Networking, for linking to the destination. Wireless transport layer security, for establishing end-to-end connectivity. Wireless transaction protocol, wireless session protocol, wireless application environment, for running a web application, example, mobile e-business. Concept of mobile computing. Mobile computing, the process of computation on a mobile device. In mobile computing, a set of distributed computing systems or service provider servers participate, connect and synchronize through mobile communication protocols. Provides decentralized computations on diversified devices, systems and networks which are mobile, synchronized and interconnected via mobile communication standards and protocols. Mobile device does not restrict itself to just one application such as voice communication. Offers mobility with computing power. Facilitates a large number of applications on a single device. Ubiquitous computing refers to the blending of computing devices with environmental objects, a term that describes integration of computers into practically all objects in our everyday environment, endowing them with computing abilities, based on pervasive computing. Pervasive computing. Pervasive means existing in all parts of a place or thing. Also called as pervasive computing when a set of computing devices, systems or networks have the characteristics of transparency, application-aware adaptation and have an environment sensing ability. Transparency. Without the impact of location due to mobility, the access protocol deployed software or hardware component failure. Adaptability. Adaptability to the environment. Environment. Present location, surrounding devices and computing systems, present data, available network, hardware or software components. The next generation of computing which takes into account the environment in which information and communication technology is used everywhere by everyone and at all times. Assumes information and communication technology to be an integrated part of all facets of our environment such as toys, computers, cars, homes, factories and work areas. Takes into account the use of the integrated processors, sensors and actuators connected through high-speed networks and combined with new devices for viewing and display. Pervasive computing devices. are not PCs or handheld, very tiny or even invisible devices which are either mobile or embedded in almost any type of object. Novel applications. Mobile computing systems have a large number of applications. It has very recently made mobile TV realizable. The Ultra Mobile PC unveiled in March 2006 has the size of a paperback book. Some of the recent novel applications of mobile computing are smartphones, enterprise solutions, music, video and e-books, mobile commerce, mobile check, mobile-based supply chain management. Smartphones. A mobile phone with additional computing functions so as to enable multiple applications as given below. SMS, short message service, MMS, multimedia messaging service, phone, email, address book, web browsing, calendar, task to-do list, pad for memos. Compatibility with popular personal information management software. Integrated attachment viewing, SureType keyboard technology with QWERTY style layout, dedicated send and end keys, Bluetooth capability for hands-free talking via headset, earbuds and car kits. EVDO support enabling the device as a wireless modem used for laptop or PC. Speakerphone, polyphonic ringtones, 64 MB memory, bright high-resolution display supporting over 65,000 colors. Email, Wi-Fi, GPS, web browser, live TV. Example of features on a recent smartphone. Enterprise solutions. Enterprises or large business networks have huge database and documentation requirements. Refers to business solutions for corporations or enterprises. This may include specialized hardware or software programming to help in management of contents with respect to storage, security, revision, control, retrieval, distribution, preservation, destruction of documents. An enterprise solution architecture for a BlackBerry device. Mobile computing application to music and video. Example: Apple iPods enables listening to one's favorite tunes anytime and anywhere. View photo albums, slideshows, video clips. Figure: some features of Apple iPod. Mobile check. Mobile-based payment system. Activated through text message exchanges between the customer, a designated retail outlet, and the mobile service provider. Service provider authenticates the customer and activates the customer account to transfer money to the retailer account. Customers need not carry credit cards in their wallets for shopping anymore. Mobile commerce. Stock quotes in real time or on demand. The stock purchases or selling, bank transactions, retail purchases, supply chain management, e-ticketing, booking cinema, train, flight and bus tickets. Mobile-based supply chain management is used by the sales force and manufacturing units. Limitations to mobile computing. Resource constraints, battery needs and recharging requirements. Interference in wireless signals affecting the quality of service QoS. Bandwidth, constraints due to limited spectrum availability causing connection latency. dynamic changes in communication environment, variations in signal power within a region, thus link delays and connection losses. Network issues. Issues relating to discovery of the connection service to destination and connection stability. Interoperability issues. The varying protocol standards. Security constraints. Protocols conserving privacy of communication may be violated. Physical damage or loss of mobile device is more probable. Limitations of mobile devices. Mobile devices are limited in various ways such as quality and security of service, energy constraints in devices, hardware limitations. Quality and security of service. Technical restrictions and practical considerations make it difficult for service providers and device manufacturers to ensure that the mobile device operations run uninterrupted. Maintaining quality of service along with the provisioning of seamless access to all users. Some of the limitations with respect to quality and security are as follows. Accessibility. Smart labels on packages have limited access because their transmitted signals are low in power. These labels can only be read within short ranges. RFID access is limited to ranges within line of sight. Range. Signal strength is inversely proportional to the square of the distance from the transmission source. There is also degradation of signal quality due to reflection, scattering, and diffraction. Access to a mobile device is limited to the range up to which the signal strength is such that it can be separated from the noise. Security. Unsolicited advertisements and unwanted messages. Virus attacks. Hackers render it functionless or threaten integrity and security of the data stored on the device. Noise signals transmitted by an attacker can jam a mobile device. Repeated transmission of unwanted signals by an attacker can drain the resources of the device. Energy resources depleted fast when computations are forced and authentication algorithms are run repeatedly. Connectivity. Connectivity loss or intermittent connectivity in certain situations. The atmospheric condition and changes in environment affect signal strength. In the event of heavy rain, there may be complete loss of connectivity. Mobility. Non-availability of an access point or base station. Infrastructural issues. No base stations or Wi-Fi hotspots providing connectivity and access to the internet to sensors, labels, automotive systems, RFID tags, and cell phones. Use of different standards in different regions limits the operability. A GSM phone may not be operable in all the continents, hence hampering global roaming for the user. Some service providers may not be able to provide connectivity in all parts of the country or in other continents, etc. Energy constraints in devices. All mobile devices have limited energy stored in battery. Battery size and power limited due to considerations such as size, weight, and bulk of mobile devices. The devices need to be recharged after short periods of time. In this way, energy availability also limits device mobility. Some devices such as smart cards, smart labels, remote sensors, and actuators do not even have a battery of their own. They derive their energy from the radiation received from a wireless source in vicinity. Such devices, therefore, require these sources to operate. Energy constraints in devices, mobile computing strategy. Processor circuit dissipates higher energy when its clock frequency higher. Computational speed higher at higher clock frequency. A device is therefore programmed so that only computations such as graphic image processing run at full processor speed. the clock frequency reduced for the other computations to save power. The clock is activated only when a device interrupts or starts processing instructions. Many innovative mobile computing strategies adopted to mitigate the effects of energy constraints on mobile computing. Use Zigbee protocol, a lesser stack size as compared to Bluetooth, so less energy dissipation due to lesser computational requirements. When a host or hotspot seeks certain data from a device frequently, program adapts itself so that the frequently required data is calculated and stored in a buffer from where it can be sent at slow clock frequencies on demand from the host. A program can also just transmit any changes in the data with respect to previous data. Communication scheduling strategies are adopted. Frequently required data transmitted as per a schedule. This saves the host energy which would otherwise be required for sending commands, and also saves the device's energy that would be dissipated in processing the commands. Processor design. Innovative circuits of mobile device processors have been designed and are continuously improved upon so that the same program instructions process with lesser energy dissipation per unit computational speed. Examples of energy-efficient processors ARM and Tiger Shark. Transceiver design and programming strategy. Design such that the signals of just sufficient strength transmitted to the receiver. Just sufficient strength means that the signal strength is low but clearly distinguishes noise and maintains message integrity. Control commands from the host are sent at lower signal frequencies. Once the device is ready and gets powered up, the transceiver transmits the data for operation. Multi-hop routing reduces the distance up to which the signal is required to travel. Hardware limitations. Besides energy limitations due to battery size, all mobile devices face various other hardware constraints too. Memory. Constraints on memory. Most mobile devices do not support hard disk drives and CD drives due to size limitations. Innovative forms of memory designed and are continuously improved upon. Internal flash drives and the card slots for external memory are used. Memory stick used to enhance the memory in the device. Bandwidth. Availability of bandwidth is limited by the frequency spectrum that a regulator allots to a service provider. A regulator regulates the frequency and signal strengths permitted. A service provider is not permitted to air signals at any random frequency and signal strength. The service must use the frequency spectrum allotted to it in an efficient manner. Multiplexing and coding techniques help in achieving efficient transmission. The technology in use also limits the spectrum efficiency. For example, CDMA has higher spectrum efficiency as compared to GSM. Limited bandwidth may become an obstacle to seamless connectivity and quality of signals aired when a large number of mobile devices simultaneously demand network connectivity. When multiple users try to use the network simultaneously, for example, on events like New Year's Eve, networks are jammed or unable to offer connectivity due to bandwidth constraints. Mobile devices. Mobile smartphones, smart mobiles and systems communicate with other phones using a cellular service provider network. Packed with smart functions and are available in smaller sizes. Applications of mobile phones no longer confined to telephonic communication. Can synchronize and upload and download data to and from PCs. Provides email and internet connectivity. Click pictures and prepare albums. Includes a personal information manager (PIM), a handheld computer and an entertainment device. Pack in everything from a computer to an FM radio and from video recording to TV viewing. Broad categorization of mobile devices. Smartphones, hybrid cellular phones that possess some advanced functionalities of multi-phones or multimedia phones besides functions of regular mobile phones. Smart cards, a mobile computer chip sandwiched within a very small space between the layers of the card. Smart sensors. Sensors in a mobile device enable it to interact better with its surroundings. Deployed smart sensors connect and convey essential information to mobile control systems. Smartphone features. A mobile smartphone is a handheld computing device offering the below features besides voice communication: a GSM, CDMA or tri-band wireless radio interface to a cellular network provided by a mobile service provider, LCD display or touchscreen, a smart T9 keypad. T9 stands for text on 9 keys. A smart keypad is one that remembers previously keyed entries. A text input system that offers an alternative to a QWERTY keyboard's multi-keys by multi-tapping same key. Functions as a phone as well as PIM, Personal Information Manager, phone contacts, address book, task list, calculator, alarm and calendar. Ability to send and receive SMS messages. Ability to send and receive MMS, Multimedia Messaging Service, messages for transmission of digital images, video clips and animations. Data synchronization for connecting mobile device to a PC. Provisions for games, e-commerce and e-ticketing. Bluetooth communication with PCs and neighboring devices. Integration of location information, GPS and maps. WAP, Wi-Fi or Internet enabled for web page access, download and other web-based applications through a WAP gateway or proxy or XHTML-based page access. Multimedia features in smartphones. Offers multimedia functionalities. Can play MP3 format audio and MP4 format video files. Some phones may also support other formats such as WMA, AAC, etc. Include cameras for still pictures and video recording. Some phones also offer picture editing softwares which enable the user to edit, crop and refine pictures on their cell phone handsets. Possible to watch TV on a mobile phone using 3G HSPA, CDMA, EDGE, EGPRS connectivity. Many mobile service providers link up with various TV channels and enable users to enjoy mobile TV on the LCD screens of their cell phones. Mobile phone gaming enabling users to play networked multiplayer games. Digital music players. These players include software that play music files encoded in formats such as MP3, WMA, real media, etc. on mobile PCs and laptops. Use flash memory. Capacity may vary from about 128 MB to over 80 GB. Present-day media players enable video as well as audio playback. Apple iPod. Simple user interfaces and designed around a central scroll wheel. Uses Apple iTunes software for transferring, storing, managing and playing music and videos and displaying photos. Provides data synchronization between iPod and PC. Other features of mobile devices. Bluetooth. Creates personal area network. Transfers data with high-level security. Consists of 8 network devices in one picocell. A picocell is within 10-meter distance. Accepted open wireless technology as per IEEE standards for exchanging data over short distances. Uses short wavelength radio transmissions in fixed and mobile devices. Wi-Fi. Supports data transfer at high speeds. GPS. Global Positioning System, also known as Geographical Positioning System. Mobile systems can have a GPS receiver or can be provided the GPS location through its service provider. Receives signals from various GPS satellites orbiting Earth. Gyroscope. Sensor which measures the change in velocity, angular acceleration as well as change in direction, angle. These measurements are used in mobile gaming applications running on a smart device. Accelerometer. Sensor which detects linear acceleration along three axes X, Y and Z. Detects up and down, right and left and front and back acceleration given to the device by the user. Digital compass. Shows directions north, south, east and west. Magnetometer. Enables three-dimension interactions without touch from nearby mobile device. Software monitors the changes in magnetic fields around the smartphone and identifies the user's gestures. Camera. Provides autofocus, xenon or LED flash for pictures and videos. 2D and 3D graphics and HDMI, high-definition multimedia interface. HDMI is a compact audio-video interface used for transmitting digital data without compression. Handheld pocket computers. Pocket-sized PCs. Differ from smartphones and multimedia phones in that they can be programmed for customized applications. Offer a variety of application and programming tools not included in new generation mobile phones. Unlike smartphones, which usually use the text on 9 keys format, handheld computers have full text keypad or a touchscreen keypad. Stylus generally used to enter data into handheld devices such as PDAs and palm tops. Some allow the user to write on the screen using a stylus and incorporate special software for handwriting recognition. Include word processors and spreadsheet software as well as PIM software. Handheld pocket computers differences with laptop. Pocket PCs do not have CD drives and hard disks. Use flash memory or micro SD card. Allow the insertion of a memory stick. A memory stick is a removable flash memory card. Clock speeds of pocket computer processors are limited up to 200 MHz due to considerations about battery life. Unlike laptops and notebooks, which use regular microcomputer operating systems, pocket computers have specially designed operating systems scaled to the requirements of the software, hardware, and peripherals used in handheld computers like Windows CE, Windows 7, Mac OS 4, and Android. Smart systems have embedded computational devices, provides comfort, efficiency, and remote access to devices and appliances. Smart cards, labels, and tokens are widely used in consumer goods and service industries. Sensors and actuators are electronic devices that make automated systems possible. Smart systems, smart cards, also known as integrated circuit cards (ICC). Small pocket-sized cards with electronic processing circuits embedded. Some act as memory cards for storing data. Can also have embedded microprocessor circuits. Do not have batteries. Energy is provided by card reader. Examples: credit debit card, ID card, access card, library card. Smart cards, contact smart cards, have small gold-coated pins on the chip providing contact with the electrical circuits of the card reader. Requires insertion into a smart card reader with a direct connection. Physical contact allows transmission of commands, data, and card status to take place. Contactless cards communicates with card reader using radio frequency induction technology, have to be held close to the reader antenna. Smart systems, smart labels, has a processor, memory, transceiver, and antenna similar to a contactless smart card. Label differs from a card in terms of thickness and visibility. Powered by the received signals. Since wireless communication is used, label need not be visible when implanted into a product or package. Smart labels are networked together using a central reading or computational device, host or PC. Cluster of labels form a network similar to a LAN network. Smart systems, RFID. Automatic identification method for remote storage and retrieval of data on RFID tags. RFID tags are objects tagged on to people, products or animals to enable their identification using radio waves from a nearby source. Contains integrated circuit and antenna. Smart systems, smart tokens. Tokens are used for authentication purposes before an action, such as granting entry into a restricted area. Smart token is an encapsulated circuit consisting of embedded processor and memory. Sizes are small, usually like a shirt button or pen nib. Uses either a wire-based protocol or contactless communication. Smart systems, sensors. Electronic devices that sense the physical environment, temperature, pressure, light, etc. May be a sophisticated set of tiny devices. Smart sensors are the sensors with processor and memory. They have computational, communication and networking capabilities. It consists of the sensing device processor, memory, analog to digital converter ADC, signal processing element, wireless infrared receiver and transmitter. Generally programmed using assembly language or C. Smart systems, actuators. Receives commands or signals from a network, mobile device, computer or controller and accordingly activates the physical device or system. Sensor-actuator pairs are used in control systems. Smart systems, smart appliances. With automation technology, it is possible to control home appliances and security systems using a cell phone or computer. Appliances can be networked using power lines which induce signals. These signals can be communicated from one appliance to another, forming a network. Devices can also communicate through a central server or short-range wireless protocols like Bluetooth or Zigbee. Can be web-enabled devices connecting to the internet through a residential gateway. Can also be allotted a number by the mobile service provider which can be controlled using SMS service. Smart systems, set-top boxes. A sophisticated computer-based device. It has data, media and network processing capabilities. Interconnects the home TV and broadcasting service network. Java is the most commonly used programming language. Runs deciphering and encrypting software. Conclusion. In this chapter, we have covered the following in detail. Concept of mobile computing, basic architecture, mobile devices, limitations of mobile devices.